by factoring everything. So if I look at the numerator of this first fraction, how do you factor x squared minus 1? Difference of squares. Alright. My denominator, x cubed minus 1. Okay, that one is a difference of perfect cubes. Remember the formula for cubes? You have a cubed minus b cubed factors into a minus b, a squared, plus ab plus b squared. And I told you didn't have to memorize that one. So when we have x cubed minus 1 is just 1 to the third. So in my formula, my a is my x and my b is my 1. Factors into x minus 1, x squared plus x times 1 is x, plus 1 squared is 1. If I am going to divide fractions, what do we have to do? Change it to a multiplication. So we are going to flip. So what was on the bottom is actually going to come up to the top. How would I factor that? Grouping. Okay, I'm going to go out to the side and factor that. So the first parenthesis, you take out a y. That leaves x minus 2. What can we take out of the second one? 3, and that leaves x minus 2. So now they both have an x minus 2. You can take that out, and we have a y plus 3 remaining. And again, that's on the numerator because we flipped our fraction for the division. Last one, we're going to do grouping again. So first two parentheses, we can take out an x. If there's nothing you can take out, what do we put? A 1. So if we take out the y plus 3, that leaves us with x plus 1. Alright, so these are more work up front in terms of factoring everything. Now, we have to cancel anything that shows up on both the numerator and denominator. So this one we have an x minus 1 on top and bottom. Here we have y plus 3 on top and bottom. And remember, it could be in different fractions as well. We have an x plus 1 in this one, and on the bottom over here. So all we are left with is x minus 2 over x squared plus x plus 1. That was from Friday. Remember, factor, reduce what you can. Any questions there? Okay. Today, I want to talk about adding fractions. If I want to add or subtract, what do we have to have? If I said like, let's just go 2x plus 1 over 5 plus 3x over 5. Can I add those fractions together? Yes. Why? Same denominator. The bottom of the fraction has to match. If they do, when you add them, the denominator stays the same. It's still a 5. We just add the tops together. So 2x plus 1 plus 3x. You add like terms and you get 5x plus 1. Okay, so if the bottom is the same, you add the tops. Bottom doesn't change when you add them. What if I had said 8 over 5b plus 3 over 4b? Do we have the same denominator this time? We have to get a common denominator. Okay, so you're looking at the things being multiplied together. Both of them have a b, so we're good there. Look at your coefficients, 5 and 4. What can you turn both of those into? 20. So you would have to take this one times 4 on both the top and the bottom. This one has to get multiplied by 5. And we do it on both the numerator and denominator so that we aren't changing the original problem. So that gives me 32 over 20b plus 15 over 20b. Now my denominators match, so we add the tops together, so we get 47 over 20. Always make sure, does this reduce at all? Like if it were 48, we would have to reduce them. 47 does not. 47 over 20, we can't divide them both by anything, so that's our final answer. All right. What if I gave us this problem? Do we have a common denominator? No. But they're very close, aren't they? Yeah. X minus 3 and 3 minus x, what's the difference? A negative. So all you have to do is take one of these and multiply by negative 1. This out here to the side, x cannot equal 3, that's just your domain that we talked about Friday. Remember on the bottom of the fraction, the bottom can't be 0. You'll see that sometimes on the Math Excel, it might be included there. If you're taking the ACT, they always include that. It doesn't change how you solve your problem at all. So if you want, you can just kind of ignore it in terms of solving this problem. We know we need to make the bottoms the same. Easiest way to do it is just multiplying this one by negative 1 on top and bottom. 2x of x minus 3 plus negative 5. This would be negative 3 plus x, which is the same as x minus 3. So now, when we add them together, my numerators are not the same, so we can't actually combine them. So it'll just be 2x minus 5 over x minus 3. Is that one okay? Let's do one that requires a little more thought. Okay. First, this one is set up to help us that our denominators are already factored. If they weren't, I recommend factoring the denominators first because you don't want to make your problem more complicated than it has to be. So first step is always going to be to factor our denominators. Now we have to look at these factors and create a common denominator. So this one has an x minus 3. Does the second fraction have it? No, so we'll multiply by x minus 3 on top and bottom. Okay, next we have an x plus 5, but the second fraction already has that, so we're good. What does the second one have that the first needs? Okay, so I'm going to multiply by x minus 5 on top and bottom. So when we do that, if I distribute, we get 4x minus 20 over my denominator, just the 3 parentheses written in any order, minus 6x minus 18. So we're multiplying out the top, but not the bottom. If we have a minus here, what do I need to do with that? Change it to a plus and distribute a negative through the top of the second fraction. Now my denominators match. When you add them, the denominator doesn't change, so I still just have all of those parentheses. So combining like terms, 4x plus negative 6x. Negative 20 plus 18. Negative 2. We certainly could factor the numerator now. I could take out a negative 2. But my directions didn't specify that it had to be factored, so we're just going to leave it like that. Is that one okay? Do you guys feel like you could try a problem? Let's not do that one. Let's do, I'm going to add one. So you have to get a common denominator, even though there aren't parentheses written. We can't factor this, so you have to think of this as an x plus 4 in parentheses, and x minus 2 in parentheses. Why don't you try it? So the first one, you may not be done, but let's check and see if you're on the right track. The first one has x plus 4 on the bottom. What does it mean? So I'm going to multiply top and bottom by x minus 2. The second one has x minus 2 on the bottom. What does it mean? It is up to you. You can leave the denominator as x plus 4, x minus 2. You could multiply it out. Just make sure if you did multiply it, you would FOIL. Most of the time, I'll probably just leave it factored, but certainly if you had x squared plus 2x minus 8, that is correct on the bottom. On the top, though, since we are going to add like terms, we do need to multiply this out, so we have to FOIL. So we get x squared minus 2x and minus 3x is minus 5x. Negative 3, negative 2 is positive 6. Okay, over here we have our denominator. On the top, distribute x, so we get x squared plus 4x. Denominators match, so add the numerator. X squared plus x squared is 2x squared. Negative 5x plus 4x is negative x plus 6. Questions? Alright, let's try just a couple more. So I'm almost done. Maybe don't want to try to get a common denominator yet, because I really don't want to multiply this one by x squared minus 1 and this one by x squared plus 3x plus 2. What should we do first? Factor. We only need to factor the denominators here. So multiply to 2 and add to 3 would be 2 and 1. Back there. X squared minus 1 would factor into x plus 1, x minus 1. Once it's factored, it's a lot easier to see what we need to multiply by. The first one has an x plus 2, the second one doesn't, so it will get x plus 2. They both have the x plus 1, so we're good there. The second one has x minus 1 and the first doesn't, so it gets x minus 1. So if we distribute, we get x squared minus the x over x plus 2, x plus 1, x minus 1. I'm not multiplying that out, I'm just leaving them. For the second one, you have to FOIL on the top. So if I have 2x minus 3 times x plus 2, we get 2x squared plus 4x and minus 3x would be a plus x. Negative 3 times 2 is negative 6. Have I lost anyone? Then we add 2x squared plus 1x squared would be 3x squared. Negative x plus x, those are going to cancel, so we get 3x squared minus 6 over x plus 2, x plus 1, x minus 1. Do we need more of these problems? Get income denominator. Make sure your denominators are factored before you try to create that common denominator. The last type of problem I want to show you, these are called complex fractions. Sometimes you are given something very ugly to simplify. Okay, we know we can just really ignore this domain piece, just get used to seeing it, but it doesn't change our problem. If I ask you to simplify this expression, we know that we cannot have a fraction in a fraction. So we have to get rid of that. You have two different routes you can do it. You can create a single fraction on the top and bottom. So basically I'd have to get a common denominator and put these together. This one is already a single fraction. And then we can flip and multiply. That's option 1. Option 2 is basically multiplying to get rid of your fractions. Because we know it's legal if we multiply both the numerator and the denominator by the same thing. This is probably the faster, it's kind of the shortcut, but we need to make sure we understand it. If I look, my denominators are 2 and 4. What number could I multiply by that would cancel both of those coefficients out? 2 would cancel this one. Would it be enough to cancel the 4? So what would I have to go with? If I just did 4, okay, that would cancel this, and 2 divides 4 even. What else do we have on our denominator? X. So we have to multiply both of these by an x, top and bottom. Now we're just going to distribute. So 1/2 times 4x. So 1/2 times 4 is just 2. And we still have our x. If I multiply it to this one, the x's would drop. On the bottom, my 4's dropped, so we have the x. So that would be x squared plus 3x. And that's our final answer. So when you have a really nasty looking expression, fractions within fractions, you can just choose to multiply by something to cancel them. If I did, let's say, 5 minus 3 over x divided by 8 plus 2 over x. What would I have to multiply by? X. The only thing I have in my denominator is an x, so we're just going to take everything times x. Then you distribute it. So 5 times x would be 5x. 8 minus 3 divided by x times x, they would cancel, so we just get 3. On the bottom, 8 times x would be 8x. Plus, here the x's cancel and we get 2. And that's our final answer. Do you guys have any questions?